All right, so as I was saying in the previous video, many things classify as cyclones, right? Many things starting from tropical depressions, tropical dispersions, tropical storms, hurricanes. So many events that occur in the world every day would classify as a cyclone. So you can't really name all of them or else you would run out of names really fast. So only a small percentage of these cyclones are going to be given names. Extratropical cyclones sometimes, are named depending on the origin. Sorry, I'll correct that for you guys. But usually they are not. Okay? So a tropical depression that develops into a tropical storm is given a name by government forecasting centers. So it only gets given a name as a tropical storm once the winds within this storm are 63 kilometers per hour or greater. Okay? In the Atlantic, how we do this is we have 6 different lists. So as you're seeing there in the image to the right, there are 6 different lists. In this particular case, it starts in 2014 and it goes all the way to 2019. Once 2020 comes, the ones that happened in 2014 will be repeated. So those 6 lists are pretty much being alternated. They're rotating on a 6-year basis. And within the 6 list, as you're seeing, you're going to have names going from A to W. So sorry, in the previous video I had said to Z, but I guess it's just to W. So I think that's 21 lists or 21 names per list. And these names are going to be starting with either a female or a male's name and then alternating over to the female or male. So if it started with a male, then it goes female, then male, female, male, female, and so on and so forth. All the names were chosen based on either the English, the Spanish, or the French language. So you're not going to find names that, are, say, Hindi or something. You're going to find things that are a little bit more related to the languages that we speak in the Americas, where the idea of these naming of the cyclones came about. And again, as I was saying, they repeat every 6 years. So the ones that we have for 2018 right now are going to repeat again in 2024, and then again in 2030, and then in 2036, and so on and so forth. So whenever you have names of very deadly or damaging hurricanes, these names are removed from the rotating list. So for example, Hurricane Katrina, which happened in 2005. So 2005, 6 years after that, should have been 2011. 6 years after that, should have been 2017. So if you go to the list of 2017 and we look for K, it's no longer Katrina, it's Katya. So because Katrina was pretty damaging, we took it out of the list and it remained kind of like a historic event. So it no longer falls within that rotating basis for the damaging cyclone names. Okay. Also, if there are more than the 21 large cyclones every or that particular year, what they do is that they will start naming the cyclones after Greek letters. So if, say that in 2018 we went all the way to William and there was still another big tropical storm or hurricane, then we would name it, say, Hurricane Alpha, and then if there was another one, we would maybe say Tropical Storm Beta, and so on and so forth, okay? So if you run out of these names in the list, because there's way too many cyclones, then you go on to naming Greek letters. First, we're going to go through tropical cyclones and then through extratropical cyclones. So a tropical cyclone is going to be a large thunderstorm complex that is rotating around an area of atmospheric low pressure, right? That has formed usually in warm tropical or at least subtropical ocean water, okay? So again, it's going to be a large thunderstorm complex that rotates around this low atmospheric pressure that is forming in a warm tropical or at least subtropical ocean water, all right? So you can have lower intensity tropical cyclones, which are usually tropical storms, and then higher intensity ones, meaning the wind speeds are going to be greater, which are called hurricanes. And usually hurricanes have got to have winds that are sustained So meaning they have to have continuous winds of 119 kilometers per hour or greater. Okay? So most of the tropical storms, and later on becoming hurricanes if they ever do, form as, or they start out as, tropical disturbances. So tropical disturbances are going to be unsettled weather in an area that is 200 to 600 kilometers in diameter that has thunderstorms undergoing within that area for over 24 hours. Okay? So again, just to kind of give you a perspective, 200 to 600 kilometers is something like 1,200 to 400 miles or so. Or not 1,200, 120 to 400 miles or so. Okay? All right. So a tropical disturbance is usually also associated with troughs. So if you guys remember from last week, troughs are going to be areas that have low pressure, low atmospheric pressure, and they're usually kind of elongated. They're usually, low pressure that extends over for a fair amount of time in a line kind of a pattern. So these tropical disturbances may form like squall lines. If you guys remember the squall lines from last chapter, I would recommend you check it out. And then these squall lines, if you remember, are also called lines of convection because there is convection ongoing in that specific spot. So most tropical cyclones, again, develop from easterly waves. So easterly waves meaning that they come from the east going towards the west. So they are going to form over Western Africa for the most part, and then they're going to travel westward towards the Americas. So in this case, it's mostly towards North America, right? Usually you're not going to have any hurricanes occurring, or any cyclones really, occurring in South America for the most part. Okay. So when they are forming here forming through like near Western Africa and then traveling westward, there's going to be these troughs of low pressure that are going to be north-south trending. So that's going to be the elongated feature. And they're going to trend north-south between 2,000 and 3,000 kilometers in length. So it's going to be an area that is pretty large in terms of low atmospheric pressure. 2,000 to 3,000 kilometers is a pretty large area. And as this traveling trough, this low atmospheric pressure ridge, if you would, it's going to be moving westward, is going to do so at a speed of 15 to 30 kilometers per hour. So it's not incredibly fast, but it is, it's still we're still able to track it on a daily basis and see its change as it flows from east to west. Okay? So usually the waves are also called like the kinks within these trade winds that are going from Western Africa to the North America are caused by the local convergence east of the axis of low pressure. Okay? Which usually encourages the air to rise and also for clouds to form. All right, so that local convergence in the east of the axis of low pressure is what makes that air to rise and the clouds to form in the lower altitudes. So west of that wave axis, you're going to have the winds diverging and clear skies dominating. So again, east, you have formation of clouds. West of the axis, you're going to have, those divergence and the clear skies. Rather. Okay? So on the satellite imagery, because of this pattern, you usually see this kind of cloud patches as you're traveling from east to west. So in this particular image that you're seeing here on the left, you have one tropical disturbance developing over here. Then you have this clear skies on the west of it. And then you have another tropical disturbance. You're seeing that for the most part it is in the eastern part of it that you have this convergence and cloud development. Then you have very clear skies to the west, and then you have the same pattern ongoing for this other patch. So you have this continual kind of formation of cyclones undergoing in that tropical area, Western Africa, moving towards North America. Okay. So again, as I was saying, I was talking about the tropical disturbance in the previous slide. So a tropical disturbance could become a tropical depression. That would be the, order in which it would go from, less, what they call damage or possible damage to more possible damage. So once it is a tropical depression, winds are going to increase and spiral around the area of disturbed weather to form this low pressured center overall. So it's starting to look a little bit more hurricane-y, if you would. So what happens is that the warm, moist air that is drawn into this depression behaves kind of like a spinning ice skater, if you would, who is drawing their arms toward their body. So when they do this, if you have seen any ice skaters, their speed increases a lot because all of the mass that they had going outwards is now concentrated, and so they're able to spin a lot faster. So that's what's happening with the tropical depression. It's going from, a very large area as it was in the tropical disturbance, and that warm air is starting to draw within its, like, closer to its center, and so it's able to spin faster. So that's what's going on. So if these winds of the tropical depression get over 63 kilometers per hour and they are sustained at this speed or higher, then they're going to become a tropical storm. And then once it becomes a tropical storm, it receives one of those names that we saw in a couple slides ago from the lists. Okay, so usually tropical storms, they can be very damaging as well. They may bring as much water as hurricanes, actually, in fact. But their wind speeds are not going to be as great, but they might bring just as much water, which causes most of the damage anyways whenever they hit any human population. I should clarify that not all tropical disturbances are going to be tropical depressions, and not all tropical depressions will turn into tropical storms. And again, not all tropical storms will turn into hurricanes. Some tropical disturbances will stay that way. They might go to tropical depressions and then no longer advance any further, and so on and so forth. So you get the idea. They don't all have to go through this, increasing speed and increasing power energy as they move westward. Okay, so some conditions that are required for hurricane formation are going to be that you have warm ocean waters. So these waters usually have to be 26 degrees Celsius that extend at depth at least for 46 meters or more. So they have to have 26 degrees Celsius is pretty warm. It's like room temperature. So room temperature waters for fairly large depths. So that's why they only form in these tropical waters, for example. Okay? So the atmosphere must also cool fast from the ocean surface upward. So that way, if you have this cooling fast of the air, the air can actually become unstable and convect, causing this condensation towards the top. So if you guys remember from the previous lecture, when you have unstable air is when you start to get cloud formation and condensation, okay? So whenever you would have layers of warm air on the top rather than cold, that would basically stop this condensation and it would make the environment stable rather than unstable. If you have stable air, then you're not going to encourage this tropical formation. So a layer of warm air is going to just stop the hurricane formation. So you also need little vertical wind shear. So that means that the winds aloft will also stop for hurricane formation. So you don't need winds at the top. If you have like a jet stream or something, that's not going to help the hurricane formation as it undergoes there. It's going to disrupt it completely. And lastly, you will need that the disturbance has to be far enough from the equator, so that way the Coriolis effect is strong enough to cause that rotation to take place around the region of atmospheric low pressure. Okay, so it has to be north or south enough from the equator for the Coriolis effect to take place. So that's why they usually happen at least 5 degrees north of the equator, and again all the way to like 20 or 25 degrees, so that they can be still warm ocean waters.